Welcome everyone. In this SOLIDWORKS simulation users primer for 3D Experience, we will be looking at the analysis of a crank assembly in both SOLIDWORKS and 3D Experience. Before we actually start that analysis, I do want to go over the approaches used, as the sequencing I will cover in this primer is significantly different to that in a SOLIDWORKS study. So let's get started. In SOLIDWORKS, simulations are contained in studies. A single model can have many studies, but each study has the same approach, with the study gathering all aspects relevant to the simulation together. Each study has its own feature tree that can proceed top-down. The stages for each study would be to set the study properties, so this would be nonlinear geometry, time-stepping controls, etc. In the parts branch would be choosing what parts to exclude and assigning a material if one isn't assigned on the geometry, or an alternate material for analysis if desired. This is also the area where parts can be made rigid or simplified to shell or beam representations. Then there is the connections branch, where a global contact interaction as well as local contact interactions can be set. In addition, this is where other connections between parts can be set, such as virtual bolts. Then there's the fixtures branch, where restraints on the model are applied. Similarly, there is the external loads branch, where loads on the model are applied. Then there is the meshing branch, where global and local mesh controls can be set, as well as defeaturing options such as finding fillet features and suppressing them is done. The study is then run. Then there is the results branch, where post-processing such as contour plots are managed. 3D Experience does have some roles which combines all stages of an analysis together to provide a seamless approach. However, we aren't going to consider those here in this primer, as the expectation is this is for SOLIDWORKS simulations users who need more control on the analysis. In general, for analysis 3D Experience uses a model, scenario and results approach, each of these being handled by separate apps. This does require more complexity than keeping everything together in a single study, but by breaking the process down into these discrete chunks, it allows for more control and more options within each stage. This is already done in a SOLIDWORKS study. The parts, connections and mesh branches are essentially setting up the finite element model. The fixtures, external loads and the study type itself are essentially setting up the analysis scenario, while results remains equivalent to the results approach. This can be confusing, as although model, scenario and results concepts are in a SOLIDWORKS study, having them broken out as individual aspects is a new level, which perhaps seems unnecessary and arguably is for simple analysis setups. But by having them broken out, it allows for more flexibility, opening up more opportunities. Here I am showing a physics simulation, which has the model, scenario and results as the main feature tree branches. In the action bar there are commands to let you switch between the apps for these distinct aspects without leaving the feature tree. From SOLIDWORKS you can actually start a physics simulation in 3D Experience on that geometry by using the Create Structural Simulation command in the task pane. I'm not going to do that here in this primer. The intent here isn't to do an analysis as swiftly as possible, but rather to explore the various ideas and approaches in 3D Experience, then see how they compare and contrast to SOLIDWORKS simulation. As such, we will manually progress through the various concepts. Once you know the basic construction, then you can take these shortcuts and still know what happened without it being a black box. Thank you for your attention.